Assalamualaikum warahmatullahi wabarakatuh. My name is Zulkifli Bakar, manometer ECE21022C. I will present about the activity 1 resistor color code. For this picture, we can see that the first layer is the first digit, and the second is second digit, and third is third digit, and the fourth color is the multiply, and the fifth color is tolerance, and the last is TCR. Okay, for the example for this activity, we took like 82,000. For 82,000, and it tolerance is 5%. Okay, the first is we see that which color is 8. 8 is a grey color, and second is 2. Number 2 is a red color, and then for number 3 we put a 0 as blacks, and after that the number 3 color we multiply with the 100, because we get 820, and when we multiply with 100 we can get 82,000. And for its tolerance is 5. We see that gold color have a 5 tolerance. Okay, that's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nick Ahmad Amir Hakimi bin Zulkifli, AE2000008. I will explain the simulation for activity 2. So this is circuit as given in the picture. The first one is voltage source, which is DC voltage, which is equal to 10 volt. This is the emitter to measure the current before load. This is resistance set as 100 ohm, and this is emitter to measure the current after load. So we will start the simulation with resistance set to 100 ohm. We will get the value for current before load equal to 100 milliampere, and after load is negative 100 milliampere. Next, we will repeat this simulation by changing the value of resistance to 150. And when we run, we will get the value of current before load equal to 66.7 milliampere, and after load equal to negative 66.7. Next, we will change the value of resistance to 200 ohms. We will get the value for current before load equal to 50 milliampere, and after load equal to negative 50 milliampere. Next, we will change to the last value of the resistance, which is 300 ohm. And when we run, we will get the value of current before load equal to 33.3 milliampere, and after load equal to negative 33.3.
I am Nurul Ruzana binti Abdullah, AE190050.
Assalamualaikum warahmatullahi wabarakatuh. I am Nurul Ruzana. I will present activity 3 for experiment 7, which is voltage simulation and calculation. Here is the diagram I need to draw in the practice. So this is the circuit where the voltage source is 10 volts. The R1 is fixed with 200 ohms, and R2 has various value. So we start with 200. And this is the voltmeter to measure the U1 and U2 value. So when we run, it shows here that the value for U1 is 5 volts, and same goes to value for U2. The simulated value for U2 and U1 is 5 volts. Then let's try for other value for R2. I change it to 150 ohms. Then when we run, we will get the value for U1 here is 5.71 volts, and for U2 is 4.29 volts. That's all from me. Thank you.
Assalamualaikum and salam sejahtera. My name is Siti Nurlina binti Nur Azmi. My matrix number is AE190030. So right now I am going to explain about activity 4 and 5. Sorry to inform, my webcam had a problem, so I cannot show my face. So for activity 4, it needs us to find the voltage and current simulation and also calculation. It wants us to develop a circuit as shown in figure 7.7. So here is the circuit that I have set up in the simulation. For the voltage source, I use 10 volt. For the resistor 1, 200 ohm, resistor 2, 150 ohm, resistor 300 ohm, and resistor 4, 300 ohm. So now let's find out the value of voltage that flows to each resistor. For resistor 1, 200 ohm, the value of voltage that flows are 6.47. For the value of voltage for resistor 2, 3.53 ohm volt, resistor 3, 0.88 volt, 300 ohm, 2.65 volt. So here is the value of current 1, current 2, and current 3. So for current 1, I got 32.4 milliampere. For current 2, 23.5 milliampere. While current 3, 8.82 milliamp. So here is the simulated value that I've got from the simulation earlier. And this is the calculated value that I've calculated from the manual calculation using the formula. For the total resistance, I got 309.09 ohm. So to find the total resistance, I used the formula 200 ohm plus 150 ohm parallel with 300 plus 100 ohm. So it got 400 ohm. So the value is 309.09 ohm. The total voltage is same from the voltage source, 10 volt, and the total current here is 32.35 milliamp. From the formula V equals to IR, so I will be equals to V over R. So here's to find the value of voltage of each resistor. I use the formula V equals to IR. So for voltage on resistor 1, I got 6.47 volt. For resistor 2, 3.53 volt. For resistor 3, 0.88 volt. For resistor 4, I've got 2.65 volt. And here is to find the value of current 1, current 2, and current 3, I use Kirchhoff current law. So to compare the value of current on both simulated and calculated value, I've got the same value on both sides. For activity 5, questions, it needs us to show how this emitter will be connected to the light bulb circuit to measure the circuit's electric current. So this is the connection that I've set up. For question 2, it needs us to draw a schematic diagram for the same circuit. So here is the simulated circuit on Proteus. And for last question, determine the amount of voltage measured at point A and B, which reference to ground, and also determine value VAB defined here as the voltage indicated by the voltmeter with the red test lead touching point A and the black test leading touching point B. So here is the simulated circuit from for point A, which is 9 volt, and connected to the ground VA, and this is the VB, and here is VAB. I've got 3 volt. That's all. Thank you.